To demonstrate the basic peak identification process, we're going to use a spectrum acquired from a high purity copper sample. So we can start by loading that spectrum. And then set the peak ID configuration to look for copper emission lines. Set a sensible peak ID threshold value. And then, as described in the previous video, we can find and mark any peaks above that threshold value. Selecting this button in the toolbar will identify all marked peaks in the currently displayed wavelength range using the parameters set in the peak identification configuration window. Each marked peak will be compared to the emission lines in the database for the selected element ionization state combinations and be annotated with the element, ionization state, wavelength and relative intensity as listed in the database of those that match within the specified peak match tolerance. So these peaks have been annotated. Note that depending on the configuration settings, there may be more than one database emission line that matches each marked peak. In this case, the marked peak will be annotated with the details of all database lines that match it, for instance this peak here. If no database lines match the marked peak, then it will be left unannotated, like that one. Note also that the relative intensity of a peak in the database, although generally indicative of the intensity of a peak that might be seen in a Lib spectrum, should not be taken as an absolute guarantee of the intensity of any peak that is observed. However, sometimes emission lines of very low relative intensity can be matched to peaks in the spectrum. If we zoom into 310 nanometers to 330 nanometers and look at this peak, we can see that two copper emission lines with zero relative intensity have been matched to this specific peak. These can be filtered out by changing the minimum intensity value in the configuration. If we now re-identify these peaks using this amended configuration, the zero relative intensity emission lines have been removed from the annotation. Note that again, the identification is only applied to the currently displayed wavelength region. So if we zoom out to the full spectrum, we can see that the rest of the spectrum is unchanged by the application of the updated configuration. So this peak here still has a zero relative intensity emission line in the annotation. To apply the updated configuration to the whole spectrum, simply select the Identify Peaks button again with the spectrum zoomed out to the full wavelength range. That zero relative intensity emission line has now been removed from the annotation of that peak. It is possible to update the identification configuration at any time. So, for example, if we now zoom into the wavelength range 740 nanometers to 800 nanometers, and then open the configuration window and add both nitrogen and oxygen to the elements whose emission lines we wish to identify. And then we re-identify the peaks in this wavelength range. We can see that the peak at approximately 777 nanometers is now labelled as corresponding to an oxygen emission line. In the previous video we saw how individual peaks could be marked for identification. So if we move the spectrum cursor to this peak at approximately 742 nanometers, and then click on the plus icon in the spectrum title bar, that peak is now marked. If the plus icon is clicked for a second time, libsoft will then attempt to identify the marked peak using the current configuration. If no emission lines in the database match the selected peak within the specified parameters, the peak will remain unannotated, but in this instance, the marked peak corresponds to a nitrogen emission line. Similarly, we can mark and identify these two peaks. The annotation on a single peak can be deleted by clicking on the minus icon in the spectrum title bar. And if the minus icon is clicked for a second time, the peak marker will also be removed. Just put those back for now. In this way, individual peaks can be marked and identified as required. It is also possible to manually edit a peak annotation. If we go into the configuration and reset the minimum emission line intensity for copper back to 0, do that by selecting apply to all here, and then we re-identify the lines in the displayed wavelength range. The 0 relative intensity copper emission line is now annotated on this peak here. But if we move the cursor to that peak, and then click on this icon in the spectrum title bar, the annotation will be displayed in a window and can be edited directly. And the annotation on the peak is updated accordingly. Note that clicking on the edit button will actually display the annotation of the nearest annotated peak to the spectrum cursor, so the cursor does not need to be positioned precisely on the annotated peak. For example, if we move the cursor near to this peak at 742 nanometers and then click on the edit button, it will automatically snap to the nearest annotated peak and display the annotation for that peak. So we can also get rid of this 0 relative intensity copper emission line from the annotation of this peak. If we now zoom out to display the full spectrum, we can see all of the peaks that have been marked and identified. To clear all of the peak markers and annotations in the currently displayed wavelength range, simply select the Clear Peaks button in the toolbar.